So let's just start. A very warm good afternoon to everyone joining us today. United Kingdom, in collaboration with Android Connects, ICCC-NET 2024 is being organized with the objective of bringing together scientists, professors, researchers, scholars, students, and industrial experts in the field of computing and communication networks to a common forum. The primary goal of the conference is to promote the exchange of innovative scientific information between researchers, developers, engineers, students, and practitioners. It will provide opportunities for academics to receive informal, in-depth feedback through discussions and to enable them to establish contact with professionals in various countries and institutions, and also to encourage regional and international communication and collaboration. Another goal is to promote the transformation of fundamental research into institutional and industrialized research and to convert applied exploration into real time application. All the accepted papers after double blinded peer review will be published in Springer LNNS proceedings. Moving on with our keynote speaker. Our first keynote speaker, Image Tony, Director of Engineering at Google USA, Transactions on Asian and Low Resources Language Information Proceedings Journal. Prior to joining Google in 2019, Image was at Microsoft between 2012 and 19, where he led and managed the NLU and conversational engine efforts for the digital assistant Cortana, launching the first Herman Kardon Invoke speaker. At Microsoft, he also led the relevance measurement effort establishing new matrices, A/B testing, and offline measurements for Bing search engine. Before Microsoft time, between 2004 and 12, Imade was a senior researcher at IBM Research, leading several NLP's initiatives including the Watson effort around information extraction, language modeling, and automatic machine translation. Between the year 2000 and 2004, Imade was a research member at Bell Labs, Lucent Technology in Murray Hills, performing research and development on speech recognition, language modeling, and spoken dialogue system. Imade is the editor-in-chief of ACM Transaction on Asian and Low Resource Language Proceedings since 2019. He was elected to the board of IEEE Speech and Language Processing Technical Committee 2009 to 2011, served as regional representative for Region 1 to 6 US, and the associate editor of IEEE Trans on Audio, Speech, and Language Processing 2015 and 2021. He also was elected chair of Deep Dive 2019 to 20 at AAAI 2017 to 20, as well as a chair of 2019 ACL workshop on Arabic Natural Language Processing. He may serve as session chair and program committee member of several conferences and journals in the area of machine learning, information retrieval, and natural language technologies. Imade authored two books, half dozen book chapters, as well as more than 120 potent and scientific articles. I invite you, sir.
All right. Thank you so much for the introduction. So let me start by sharing my screen. I also appreciate the invite to the conference. It's really exciting to be here. Uh, all right. Um, so can I get the permission to share the screen? All right. Getting there. Do you see my screen? Is all good?
Yes, sir.
All right. Okay. Thank you, everyone. Thank you for being here. Today, I'll be talking about AI revolutionizing search, or in other words, when we said AI, mostly we talk about large language models and how it is changing the search experience. So when people talk about AI, and thank you earlier for the discussion, I start working on this from 1995, 1996, where I started doing AI and LLMs. But even though at that time it's still late in the game, the AI is coined in the 60s, and where people are using rule-based models. And for those that are, uh, know a little bit about history, at that point we talk about expert systems in the banking sector, and it was kind of a boom in the late 60s, and then we get our AI winter in the 70s, where people don't believe on those systems anymore. And we got again into second phase, and up to the 80, a lot of work, and then boom, again the AI winter. That time people try to experience that maybe there is no data, computation is limited. And then from that time, from the 90s, actually we start seeing the second wave of big data and machine learning. The internet becomes a reality. The GPUs now are available. uh, a lot of projects. I can mention AlphaGo as an example, that became available, and then we start seeing a lot of progress, whether that's on machine translation, whether that is on information extraction, speech recognition, natural language processing, and so on and so forth, many other areas. Uh, 2017, within Google, transformers come to life. And then suddenly I would say that was a kind of a beginning of a third wave, and now we are talking about generative AI, generative language model, or for other people, it's a decoder model, but still transformer based, and start seeing the generation of GPT, AlphaBall, Chat GPT-3, and then eventually Chat GPT, and then Google has also Gemini and DALI and many other models. And now we start seeing
Yes.
really that innovation in the area. Uh, I'll give you an example, and this is what I show in the other window here on the other side, on my right side, which is an example how search moved from keyword matching to now really getting into the semantics, thanks to embedding, thanks to the vector representation, thanks to encoder decoder, thanks to dual encoder. All of these technology are taking us to a different level of understanding and semantics, that not anymore keyword based as it was several years ago. So how do we arrive here? How we moved from an era of language model to the era of machine language model? So when we talk about LM, and I know that the audience, they have different backgrounds, so I wanted just to give quick idea, and I'm sure that many of you are aware, uh, giving an example of application for language model. So when you issue a query in search as an example, and you said, how is the weather? Uh, an example of language model will be to predict what is coming next. So as an example, in the issue query, how is the weather? I can say, oh, it's 26 degrees today in Bigot Mirror, as an example, right? Another example, when I said how tall is, the likelihood is maybe Taylor Swift. It's famous person in the US, and people issue a lot of query about her, and that could be the first one. So there is that idea. What I'm trying to say, that the language model, one of the goals of language model is predict what is coming next, given a context. And if you follow this, actually, this principle, of course, it's much older than 1985. But Jelinek and Mercer in 1995, they really created a formula. They come with kind of a mathematical formula around how statistics and how machine learning could be applied to this area. And now, if you take a major tech event focus on, uh, the likelihood of the following word could be AI, or could be tech, or could be venture capital, or could be innovation. And all of that is materialized through probabilities. We waited until 2000, and that's where we start observing next generation of language model. It's not anymore, conditional probability of a word given its history, But now we start applying, how to apply neural network to that. Famous paper by Bengio and all, uh, and how to apply machine learning, how to represent the problem of machine learning using a neural network. And here it was really a shift in machine learning architecture, because before we talk about counts. So when you represent the word, we have the word count, and we compute the probability as the word count. We compute the conditional probability as the word count. But now we had the paradigm shift in 2000, where now we talk about embedding, we talk about a vector representation. So now the word or the token is becoming vectors, and that helped capture semantics and the richness of the word. The context as well, it's becoming contextually aware, and we move it beyond counting. Uh, and that's, let's say, I will say, one of the big revolution in moving on this era of LLMs. Of course, without any doubt, transformer was a big shift. Attention is all you need. I think many of you here are familiar with that paper, and that added another level and other dimension to how we do neural network, how we apply neural network to several problems. Uh, One of them is language modeling, uh, and that was not far ago, 2017. So I mean, less than 10 years. And now suddenly we have this new generation of autoregression generative model. And again, as you see in this picture, what we try to do is we try to represent any input as tokens. A token could be a word, could be a lemma, could be a morph. It could be also a speech segment. It could be image passage. It could be a subword. It could be sequence of words. So the representation of token now, it becomes anything of interest. And then accordingly, with these autoregressive regenerative model, our goal is to predict what is next, given an input in context. Now, this is great. It has its limitation, even though we see fantastic progress, but few of the limitations that they may cite here. There is a constant number of computation steps between the input and the output, and that's the way the architecture is. So somehow, one could argue that we still have a weak representational power. There is another part, even though there is a lot of work that is happening, but it's still a research area, which is great to observe, that when we talk about reasoning and the planning, there is a lot of progress this year, particularly, but we still see some factual logical error. We still see some inconsistency. And accordingly, that also an indicator there is a lot of work in science to address those challenges. Okay, another aspect, so we talked about the architecture. The other aspect that we should not forget is that scaling matters. And what I mean by that, pre-trained language model, uh, they need a lot of data. So you need a larger scale pre-trained transformer model. The LM scale from 100 million parameters to currently we talk about 100 billions or more, close to trillion model parameters to get this pre-training model. So that means you need a lot of computation. It's very, very expensive. It's not everyone or every institute that can do that. You need a lot of resources for it. This is only about computation. When I said computation is not only GPUs, electricity as well to make those GPUs runs. That's also part of the equation. Now, also we talk about pre-trained on large labeled corpora with billions of tokens. And now, example of corpus available out there, Wikipedia, book corpus, Common Crawl, and so on and so forth. This is something that was not available in the past, and now you can have access to those. So in general, we observe that task performance improve along with the increase of the number of parameters of the model, as well as the number of the training data that is used. I'll give you a few examples here to give you an idea how things are working. So when it comes to arithmetics, simple operation of maths, like 1 + 1 = what? So initially, for many, well, for a lot of time, let's say, put this way, that with 10 to the power of 20 or 10 of the power of 22 of training flops, we didn't observe any behavior that telling us that you can do arithmetics when it comes to LLM. And suddenly we kept increasing the number of flops, and we start seeing magic, we start seeing movement. And suddenly now we see the accuracy moving, with 20, with 10 to the power 24 in terms of flops. We can seeing, the performance going to 30, 40%, and it keeps going higher, higher as the increase of that. So I give the example of arithmetics, but the same thing applied to figure of speech, the same thing applied to transliteration. So somehow this is also a clear indicator that computation power are playing a role. And other aspects to see that also there is plenty of models that are available up there. I know we always hear about a couple of them that are uh, highly used or adopted. But actually, if you think from 2018, even before that, there is different type of models that are open source and other that are closed source. And as you know, the type of models are different. We have encoder only type of model, that encode and decode, but not autoregression. We have encoder decoder, you encode and with autoregression decoder. And we have the decoder only, and that's where we talk about it's really meant for autoregressive, and those are the famous LLMs we talk about today, whether that is Gemini or ChatGPT or Llama or things like that. So all of them are available. Actually, it's great to see Google, as an example, have also many open sources model. Uh, Same thing for other institutions, and that's great for the research community that they can try and play with these different models and try to do some up training and make that much better. All right, so this is kind of maybe seen as a big introduction or a high level introduction to LLMs. But let me take kind of the presentation to another layer, another level here. And what I'd like to share with you is how these LLMs are influencing search engines. How in search we moved from, let's say, a keyword to sharing the top 10 or whatever, 100 documents to how we do search now. So in search, some of the capabilities provide an answer. You need the multimodal, multi-language capability. You need to simplify. You need to plan. You need to customize. You need to organize. And all of that kind of is becoming available right now. I'll try to share a video. I hope that it will work. Uh, Let me try here. Okay, I'll come back to the presentation. As you see here, so we went from a simple search to now you can search based on the multimodality, the image, as you see the example. Here we also, in terms of planning and direction, it becomes through 3Ds. You have a planning how to proceed in your search step by step and all of that. So really the experience is becoming different. I'm also going to show another video to give you other example how what LLMs can offer for search. This is another example, search specific, uh, and also All right. So as you see here, we are really helping. We moved from providing search results to helping you do search. Those planning, as you see in the videos, how you can plan what I'm gonna cook for the following 5 days, and then you have a daily plan. How I want to go to London and spend 3 days there, and I have a budget of $500, and then you have the planning every day what to do considering it to the budget you have and things of that. So this is where we get into what we call chain of thoughts, when we got into planning and things like that. So that's how I'm trying to do in the next couple of slides and introduce the aspect of chain of thoughts that is becoming big and very promising this year, actually, or let's say recently. So many of you know that chain of thought is technique that encourages AI model to break down complex problem into smaller one, manageable step. LLMs usually it provide a summary, and if something is complex and there is no steps or planning, it could go wrong. And when I said go wrong, it could be problem of hallucination, factuality, things like that. Breaking down the complex problem into small part, it helps the LLM behave better. So this is a kind of one step toward reasoning. I do agree that there is a lot of work to be done, but let's say it's one step uh, toward that area. How we do that? There is a lot of work around prompting. Uh, so the step-by-step reasoning needs prompting the model to make them ready for that. There is the reasoning, the model generate intermediate step, showing it through process. You keep iterate that, and then providing the right or the final solution. So here I'm giving a good example. You can try it if in your phone. Please feel free as an example to download Gemini and use those examples, and you'll see how great we are addressing the problem. So one of the example query was, I have a train travels at 60 miles per hour for 2 hours. How far did travel? And show the steps. And interestingly enough, the models today try to explain the way it reasons. So it started telling you, well, there is a factor to compute the distance. It's the speed times the time. Also, it tells you, oh, accordingly, given what you gave me as an input, the distance is, in this case, 60 miles times 2 hours, and that leads to a distance of 120 miles. So being able to generate plan out of the query and then execute it one step at a time, make the whole operation successful, and you can see huge progress we made. This, of course, as of today, needs a lot of computation power and a lot of latency, but at least it's a good progress, and that we are working a lot on how to make sure that to keep the latency down and get this to real time. uh, and here, as I mentioned, there is a textual reasoning, there is a code generation, there is creative writing as well. So all of these things are included in one. Uh, so this is also important for search, as I did mention. So because now we are going beyond the simple question answer, that's how search was known for or used for. By breaking down complex problem into smaller, manageable steps, we help also, analyze the information, drawing inferences, and making decision across multiple stages. Uh, why is this important for generative AI? Because it enables more sophisticated applications. As you see here in the example to the right, when you said, here is a 3 days meal plan, easy to prepare for a group, because so you see that you generate really in the daily basis, and you click on that and you get the recipes and all of that. This is different from the way search does things in the past. Uh, keep going. Uh, Again, when we talk about chain of thoughts, or we talk also about multi-step reasoning. For that, of course, the language model is always at the core. The chain of thoughts prompting guides the AI through structured reasoning process. External knowledge become important as we take the problem and divide it in small problems. sometimes you don't necessarily need always to run a large language model. Let's say part of your process, you identify that you need to compute 20 times, 60 times 2, as we said in the example earlier. This becomes an API call. And accordingly, instantaneously, you can, just run a calculator and get 60 times 2. Why you run a large language model to do those simple operations? These becomes possible because this idea of multi-steps, that you have different steps. From model's perspective, reinforcement learning here becomes key because you run the model, you want to adjust and uptrain the model, and it's very important to make the model learn from example and correct itself. And that's why there is a lot of work and there is a lot of efforts on optimizing reasoning strategies through feedback and rewards. So now I'm sure that you saw many applications. uh, the famous ones at the beginning, everyone gets excited, is the code generation. It helps save a lot of time. We saw also great example coming from images. You see, I provide this example of image, and then if I ask a question, how many muffins can each kid have for it to be fair? And suddenly, from the image, you detect the kids, you detect the muffins, you get the results, uh, and all of that on these multi-steps, step by step. So you generate your code and you try, that's kind of the different steps, and you try to execute those one by one. This is something that it's hard to do before. Now it becomes almost a reality. uh, Also, what you observed is uh, model in some applications are doing better than human. One interesting study that was done recently found that ChatGPT rated better than real doctor for empathy and advice. Uh, I'm not necessarily talking about identifying or diagnosing an issue, uh, but models has better capability to show empathy to users, at least on this study relative to doctor, and that's kind of an interesting phenomena to observe. Uh, at the same time, we start already seeing concerns. Uh, One of the concern, I don't know if you are familiar with that, but the first known chatbot associated death was in 2023. That conversation between a chat and the human ended into convincing the human to, get into not great situation, and that is a concern. Something else, which is also AI powers of political persuasions. There is a study also that was done for two use cases. There is in the US, there is a study about a bill to be signed. One of them is related to carbon tax, and the other one is related to child tax credit. So usually you try to convince people to vote, and people vote either left or right. So they observed that if when they put the machine trying to convince people to vote in one direction versus another, the machine seems to be more successful in persuasion. That's also could be concerning. Um, we also have a new generation of content farms in on the way. So there is so many data generated in the web that is not necessarily true or factual, and becomes available to be consumed, and it's all machine generated, and that is becoming also a problem. These news website proliferation online. Um, at the same time, I think we have plenty of opportunities ahead of us. Uh, there is a lot of work to revolutionize the work, automate repetitive tasks, enhancing creativity. Uh, LLMs could serve as co-creators. Personalization, a lot of work there as well happening, tailor content, product, and services. Democratize knowledge, making complex information accessible to everyone and understandable by everyone in step by step. There is also ethical consideration. Uh, I think there is work for responsible development and deployment of LLMs, are crucial to address potential bias and risks. Uh, to conclude, I think the future is bright, promising. Uh, we are getting into promising where human potential is amplified by intelligent machines. Thank you, everyone, for listening. And yeah, thank you.
Thank you so much, sir, for your wonderful words. Now, I invite our second chief guest, Upendra Kumar Tiwari, Synergistic CompuSoft Private Limited. Upendra Kumar Tiwari is a certified master AI consultant with specialized credentials including PL300, TP900, and the Data Science Professional Certificate by IBM. He has successfully led key projects such as last mile delivery optimization, dormant customer analysis, and privacy breaches in iOS apps, showcasing his expertise in solving complex business challenges through data science. Additionally, Upendra has advanced skills in generative AI, along with deep understanding of machine learning and predictive analytics. With proficiency in tools like Power BI, Tableau, and Python, he delivers cutting edge, data driven solutions that optimize processes, enhance business outcomes, and drive innovations. I invite you, sir. Due to some technical glitches, sir is unable to join. He will join within a minute. Please wait for him.
Dipanshi?
Yes, sir.
Sir has joined.
Okay. Moving on with our second keynote of the day, Upendra Kumar Tiwari, Synergistic Compusoft Private Limited. Upendra Kumar Tiwari is a certified master AI consultant with specialized credentials including PL300, DP900, and the Data Science Professional Certificate by IBM. He has successfully led key projects such as last mile delivery optimization, dormant customer analysis, and privacy breaches in iOS apps, showcasing his expertise in solving complex business challenges through data science. Additionally, Upendra has advanced skills in generative AI along with a deep understanding of machine learning and predictive analytics. With proficiency in tools like Power BI, Tableau, and Python, he delivers cutting edge data driven solutions that optimize processes, enhance business outcomes, and drive innovation. I invite you, sir.
Okay, thanks for your invitation, ma'am. So should I start?
Yes, sir.
Okay, thank you. So hi everyone, good afternoon. I hope I'm audible.
Yes, sir.
Okay, thank you. So basically, in industry, even I'll be talking about the research point of view. So whenever we work on any machine learning related problem, the main thing that we face as a challenge, and that is that how to get our accuracy. First thing. Second thing, sometime just to prepare our data, we face certain issues like what are the different feature engineering we need to do, or what are the different process we need to follow. Because whenever we work on the data science, usually we follow the CRISPR process, isn't? And you know that in that CRISPR process, we have a lot of things related to the data science and machine learning. And everybody, that the main stages that consist of starting from understanding the business problem till the deployment of the model. Here, the problem is that you need to have the strong knowledge of the feature engineering processes, strong, foundational concepts of the machine learning. And sometime, as I'll quote only one thing, that whenever we talk about the machine learning or the data science, these concepts and implementation of these are only experimental. So sometimes it takes a lot of time to decide that what is the final outcome we should have, first thing. Second thing, how we will be relying on whatever outcome we are getting. So just to, make safe for ourselves related to these issues, we can use the concept of AutoML, that is automated machine learning. And the beauty of this AutoML concept that we usually follow, that you need to have your data only. You will provide this data to some Python libraries of the AutoML, like we have the S2O, we have the PyCaret, we have the Teapot, feature tools. So we just provide the data to these library, and they will start doing each and every phases. So like as I'm saying now, so starting from data cleansing, it will be doing data visualization, it will be doing feature engineering, as well as it will build n number of models. I'm not talking about a single models. It will be building n number of models, and then on the basis of that, it will be finalizing your model. Yeah. So each and everything is starting from data cleansing till deployment. It will take care of each and every stage, and your job is just only to provide data. So this is the basic purpose of your AutoML that we have worked upon. So this is, I have just shown you about the AutoML works, that it will be starting from data preparation. It will be doing feature engineering, and you can see that it is doing model selection and hyperparameter tuning. Because sometimes what happens that, let's say you are building your model, you're working on your data, you're doing computation of it, and everything is happening. But the accuracy that you're getting, it is, let's say, 60%. And as per your problem statement, until and unless you're not getting the accuracy around 70 to 75%, then it will not work. So what you do, you do start experimenting, you do starting hyperparameter tuning. And what is the hyperparameter tuning? So it is basically, doing the permutation and combinations of different hyperparameters values. Different, I can say, the arguments of the function that we are using, its value. So just to, decide that what particular parameter value will be working upon, or doing the multiple hyperparameter tuning, I tell you, it's a very cumbersome task, as well as it's a time taking process where you need to have this different permutation and combination. So on behalf of you, your AutoML library works upon it, as well as, it start, building the multiple model, and then you can select the model which is doing best. I tell you one case study when I was working. So I was working on last mile delivery. And the problem that was happening over there, that when we were working on that last mile delivery, the purpose was to optimize the route. Optimize the route, one problem. Second thing, we need to have, we need to predict the time in minimum constant. So when I'm talking about the minimum constant means, so that, let's say, whenever you just order something on Amazon, so what happened? During the festival time, everybody don't want to wait, whether they are the prime members or whether they are the general members. If you're not able to fulfill their requirement within their desire, then somewhere the order cancellation will be done. So until unless your model is not sufficient able to, do this kind of prediction, that even with the limited number of resources, how the order of everyone within the time limit could be fulfilled. So your model should be very efficient related to this. And that is why what we do, we need to have the robust model. And for that purpose, the hyperparameter tuning is really very necessary, as well as the selection of the features. When I'm saying selection of features, that which particular parameter will have the higher impact rather than the other one, decision of this also, do a very crucial task. So this is why one thing we have that we should do, we should spend a lot of time to do this research. Or the another thing, what? So we just use PyCaret. We just use PyCaret and we provide that data to it, so that, one thing, that within a fraction of day, we were getting the entire overall idea, as well as we were getting our stipulated result. So that's why somewhere this AutoML was doing a lot in terms of work for us. So you can see that if I have to use AutoML, so how can I do that? So yes, I can use it for democratization of AI. It means what? Even though if you are not very much comfortable with machine learning, even though if you're not very much comfortable with the flora and fauna of data science and machine learning, but if you are even beginner into this field, still you can use this AutoML library and you can solve your purpose. Yeah, the time that you are taking a lot to work on it, it can be minimized by using the AutoML. Yes, see, what is MLOps? MLOps means you're making your machine learning into production, sorry. So basically, when we talk about it, so related to the pipelining, yes, we can use it. We can use it. Yeah. So, but the problem is that, see, whenever you use AutoML, as I've said to you, that even if you're beginner, you can use it. Even if you're beginner, you can use it. But the problem is that how the results is coming. The interpretation of this is very necessary. Although just, by recognizing this limitation of the AutoML, the new phase of, or you can say the advanced version of AutoML came into picture, that is known as explainable AI. But yes, there is something which is called as interpretability. So we need to, have some concern related to this. Yeah. So whenever you'll be using the AutoML, the first thing is that, as I've said to you, that everything will be automated. You just have to provide your data as per your research problem. And sir, this explainable AI is the another concept where what will happen. See, the job of the AutoML is to use the data, give the result. That's it. Interpretation of this result is going to be done by yourself. Give me 1 minute. So, sir, this explainable AI is the advanced version of the AutoML, but somewhere you can say that it is giving a agenda for the explainable AI, because whenever we are talking about the AutoML, it will be doing your work, but the interpretation of every result, it has to be done by yourself. Your AutoML is not going to help you out. But the thing is that you were doing a lot of things related to your feature engineering, pre-processing. Selection of model is very crucial. That should I go with the random forest, or should I go with the XGBoost, or should I go with the KNN? So it is just solving this problem by showing you the result as well as the evaluation matrix of each model, so that you can decide that, okay, out of this n number of model, this particular model is doing best. Yeah. And as I've said to you, that you don't have to be bothered about anything. Simple, you are providing the data, and then you just see that how the things are running. That's it. So there is no manual intervention. There's no manual intervention. Obviously, just because of that, everything will be enhanced in terms of uh, getting the result, having the efficient experiment of the problem. Yeah. So when I talk about this AutoML that we were using, so mainly our company deal with the BFSI domain, banking and finance sector. But even if you're getting the problem related to the healthcare or the genomics or any domain I'm talking about. So whether you're working in the stock related data, or you're working with the any algorithm, yes, and on the basis of the result of that algorithm, if you are creating your labeled data, and then you are again trying to apply your machine learning problem implementation, your AutoML is going to give you a very fantastic result. So this is why I have chosen this topic to discuss among you learned guys, that somewhere you don't have time, you have to get the result, you have to write the paper for it, you have to publish the result, then you have to go for the publish of this paper. So there is a lot of time that is going to take, where result matters, but as well as other things also you have to incorporate. So your result part, your experiment time can be reduced by use of the AutoML. This is just like you use pre-trained model in CNN, like ResNet 50 or Inception or B3. So in the same way, if you are talking about the machine learning, you can use this AutoML. And you will be surprised that it gives you around 30 to 35 model comparison at a time. And then you can use one of them as a pipeline of yours. So this is that I am just talking about the AutoML. And sir and ma'am, I tell you one more thing, that when we are talking about this AutoML went to this explainable AI, which actually was the foundation brick for generative AI. That how each and everything will be, your machine will be doing. You don't have to do anything. Only you have to provide the input. Yeah, I know that even in the generative AI, you don't need to provide the input also. You can just write a prompt and each and everything will be done by the model itself, the LLM model. So this concept of the generative AI basically have been intended by the concept of the explainable AI. So somewhere, there's a hierarchy of the evolution and result into generative AI. Some question is there. Okay. Yeah. So, that means if I talk about this AutoML, so somewhere I can say that the main purpose of using this AutoML to ease your work, to reduce your effort, to reduce your time, giving you better result by doing a lot of permutation combination of the hyperparameter tuning. Yeah. All right. So I have just come up with a very simple example that I'll just show you so that you can visualize that how you can use it for your problem. Yeah. So for example, although it will take time to run because it has to do each and everything. So it is going to take around 15 to 20 minutes. So I'll not run here. I'll just simple show you the outcome. And on the basis of that, you can visualize that how you can use it for your research oriented. So, respected professors, you can see here that we are going to work with the PyCaret, which is one of the AutoML library in Python. Yeah. If you're going to use this PyCaret for the first time in your environment, then you need to install it. And you know that how the libraries are installed in a Python environment. Then, we are just working on a simple data so that I can show you the entire implementation of it. So you can see here that we are working on a diamond data. Yeah. And since it's what we have the caret weight, cut, color, clarity, polish, symmetry, report, and price. So on the basis of this caret weight, cut, color, clarity, polish, symmetry, report, we are going to predict the price. So I can say that we have 7 features and 1 label data, that is price. Now you can see that it's a matter and it's a problem of regression. So now if I ask you simply that if you have to build a model that be doing some prediction of the price, so you have to go with the n number of process. Yeah. So whatever process you had to do manually by yourself, you don't have to do it. Your PyCaret will take care of each and everything. So you can see that the data that we have read, it is inside the variable data set. Now, I have taken a very small data that have 6,000 observations and 8 variable. Yeah. Now you can see here that just to work on this data, I have taken 90% of it as a data now. 10% sample I took as a new data. Yeah. Or you can say futuristic data that I'll be using it for doing prediction. So I'll consider my overall data as 5,400. And out of that, I'm going to divide them into train and test. So here you can see that the 90% sample I have taken, and this 90% is now my overall data. And you can see that I have created a new variable that is data underscore unseen, inside which I'll be taking the remaining 10%. Yeah. So this 5,400 I'll be using for my modeling and testing part. And this unseen data, I'm going to use it for my, prediction part. Isn't? So you know that since our output variable was continuous, so we have just used the regression. So, from PyCaret regression, we have imported all the libraries that may be relevant here. Now we are setting up the entire pipeline. Yeah. And here you can see that in this data, we have provided each and everything. as well as we are mentioning that the target is going to be the price column. So when we use this, you can see here that target it has decided, what is the original data shape, transformation happened or not. Transformation happened or not. So yes, you can see that you have not done it. It is automatically splitting this 5400 into train and test. Yeah. What will be the percentage? 3779? 70%. Yeah. So you can see that automatically this has splitted your data into train and test. 70% is took for training and 30% it took for testing. As well as you can see, it is saying that we have only one numerical features, 6 categorical features, pre-processing true. That means it has applied the pre-processing. And you can see here that wherever there was a missing values, it has done imputation. Yeah. For the numeric, it has done mean imputation. For the categorical, it has done mode imputation. Even wherever you had the categorical variable, just to convert them into discrete, it has done the one-hot encoding, means it has created dummy data. Yeah. As well as just to deal with just to improve the accuracy, what it did, it just did 10-fold cross validation. Yeah. It has uses k-fold cross validation and the number of fold is 10. CPU jobs -1, that means it has not used any parallel processing. Yeah. So can you see here the thing that you had to decide when you were working on this machine learning, everything has been done by the PyCaret library itself. Neither you have to pre-process, nor you have to take sample, nor you have to split your data into train or test. Yeah. Then another thing you can see that the moment we just call the compare models, so you can see here that we have n number of models. If I just count the numbers, so you can see these are the different models it has built. It has shown their performances, and you can see that for this particular data, the R2 score of your XGBoost model is best, isn't? So even it has saved your time. It has saved your time to decide that which model has to select or which model has to be finalized. It is showing each and everything. In terms of the execution of these training in second, as well as it is showing the each evaluation metrics. What is their RMSE value? What is their R2 score? Each and everything it is showing over here. Yeah. So you can see that here the XGBoost model is doing best out of whatever model it has tried, isn't? Yeah. Even if I show you here, even your random forest is also doing well. So you can see that the top 3 model is the XGBoost, ET, and RF. Yeah. Why I'm saying RF? Because these have been named as like this one. So let's say I'm just going with the RF model, random forest. Yeah. So what we did, we just finalized this random forest model. We just finalized this random forest model, and you can see here that it has gone with 10-fold cross validation. So what happens in the 10-fold cross validation, I tell you that your entire data will be splitted into 10 parts. Yeah. And at every time, one will be test and the remaining 9 will be trained. And then again, your model will be trained on the trained data and will be tested on the tested data. And in this way, you'll be getting the R2 score. Yeah. So you'll be in this way, 10 times you'll be executing your model, and then whatever R2 score you'll be getting, you'll take the simple average of this. Yeah. So sometime, let's say in the threefold cross validation, your model was having 98% accuracy. In ninth, it was 96. But when you have completed your 10-fold cross validation, after that, you just took the mean of the result. And this is the final R2 score of your random forest model. Yeah. And obviously, when you have pre-processed your data, when you build your model, when you have evaluated the model performance, you finalize the model, then you go for deployment. So even for that deployment purpose, for the final prediction, what you can do? Yeah, you can go for the deployment part. But even if prior to this, I forget to discuss, let's say you have modeled it, you just gone with the final accuracy that you got here, that is 97%. This is 97%. Let's say that you're not satisfied with it. You're not satisfied with it. What you want to do? You want to improve again this accuracy. So as I've said to you that whenever you want to, improve this accuracy, what you will do? You will somewhere do hyperparameter tuning. Yeah. For that, again, there's a function in this PyCaret that is called as tune_model. That is called as tune_model. And when you have done it, see, again, the hyperparameter tuning have been taken place. And this time, the average accuracy you're getting 95%. And earlier, you're getting 97%. That means even if you're doing the tuning of your model, it is not working much. It means what? It means the interpretation can be that either we can improve the number of folds, or you should go with, without tuned model. And another interpretation is that this is the accuracy that at most your model can achieve. Okay. So even you can do the residual plot, and you can see here that your train R2 score and the test R2 score, both are really very well, isn't? Your model is right fitted model. That is why every data points are overlapping to each other. Yeah. So in this way, you can use it, as well as you can use it for doing prediction of your unseen data. Yeah. So let's say you just finalize this model, whatever your model you had means random forest model you have finalized, and you can see the pipeline that it has won. So in the pipeline, you can see whatever as a part of pre-processing it has done, whatever it has done as a part of the tuning, it will be showing each and everything. Now you remember that when we had that data, we just splitted them into 90% and 10%. So that 10% unseen data will be using it for doing the prediction of it. Yeah. And you can see that your model has predicted. So this is the actual price your data was carrying, and this is the prediction of the price done by your model. And can you see that how much near this is? Yeah. The expected price was 12,791, and this is somewhere near to it. Yeah, 12,791, 12,030. So in this way, you don't have to do anything. You can easily use the AutoML, any particular like PyCaret or any other model, and you can use it for the further deployment. You can save this model. Yeah. So in this way, you can use the PyCaret as a part of your AutoML to work on your research problem whenever you have the large data and you want to, get the result within less fraction of time, because you'll have to pre-process it and then you'll have to select the model. So this was what I just wanted to show you as a my problem statement, that how we were using this AutoML. And I tell you another thing, that even right now we have just moved ourselves from working on Python to the cloud, where whenever either we are using this uh, SageMaker, or we are using the Azure Brick, everywhere, when whenever we are providing the data on the cloud and the cloud has started to doing the prediction, trust me guys, in background your AutoML will be working. Your AutoML will be working. And our job is just to provide the data in the bucket. So that is why this is really very important. This is really very impressive. So I just thought that I should talk about it in this computational conference. So I'm done at my side. Saran ma'am, if you have any question, if you have any query, you can discuss to me. So Aditya sir, I'm open for the question.
Thank you so much, sir, for your wonderful words. If there are any question, you may ask.
Yeah, Rashid sir, it will really, you just start to work on it in your experiments, in your research, and you'll be surprised at how wonder it is doing to get your result within a very short duration of time.
If there are any questions, you can personally message him also. Now moving on. Now invite Dr. Aditya Khamparia sir to thank our keynote speakers.
No, you don't have to pre-process your data. It will be taken care by the AutoML library itself. Yeah, thank you. Thank you, everyone.
Okay,
Thank you, sir.
thank you, Dipanshi. So, on behalf of the organizing committee, I would like to extend our heartfelt thanks to all our esteemed keynote speakers and presenters for sharing their insightful knowledge and expertise. Your contributions truly enriched the discussions and made this event a success. We look forward to see you again in our next upcoming conferences. Thank you very much.
Thank you, sir. Thank you, everyone.
Over to Dipanshi.
Now everyone can move to their respective rooms.
Everyone will start joining with its respective rooms.
Our backend team is moving you all to the new rooms. Please wait.
I kindly request that all session share and authors rename themselves with the specific session numbers, followed by their name and paper ID.
Everyone is requested to rename themselves.
I kindly request that all session share and authors rename themselves with their specific session number. Session shares should use their section number followed by their names, and author should include their session number followed by their paper ID.